Welcome back, AP Calculus students. Mr. Record here from Avon High School. We're continuing looking at some of our previous Continental Mathematics League problems. This is from the February of 2022, during the 21-22 season, Meet 2, and we're taking a look at problem number 4, just a one-point question here. It says, which of the following is an equation of a curve that intersects at right angles? Every curve that is a member of the family y equal -3 over x plus k. And this has got a really neat approach to it graphically that one could pretty much easily solve without doing a lot of heavy lifting. But I'd like to show you a more analytical way to do this, thinking about some of the rules and tricks and tips that we've learned in our calculus class. And the first clue in the problem, or the first important piece here, is this whole thing about right angles. That's a very important piece of information, because what that says is that we're talking about 90-degree angles, and we're talking about the idea of two things that intersect each other, whether they do so as a curve and a line, two lines, two curves. Because if you zoom in enough, right? If you zoom in on a curve and a line intersecting, you can trick this picture into thinking that you've got two lines, right? It's the idea of local linearity. You zoom in on a curve enough, it's going to look like a straight line. And so what I want us to start thinking about is right angles have slopes that are opposite reciprocals. That is the key element in this particular problem. And so I want to turn your attention to the given curve, this guy right here. And I want to ask you, well, how would you go about figuring out what the slope of that curve would be? What kind of calculus idea serves that purpose? And hopefully you're all sounding out in unison. Well, Mr. Record, that's the derivative, right? And so we're going to take the derivative of this, and I'm going to tell you, if it's a little bit tricky to do that initially, we could rewrite that x to the -1. And now the y prime, right? We just look over there right at it. We're going to get +3 x to the -2. Of course, the derivative of k is just 0. And so we could rewrite this as 3 over x squared. And that's basically going to serve as a formula, if you will, of the slope of the tangent line to any point that might be on that particular curve. But now use the concept of the right angle. So in other words, you need to opposite reciprocate this, right? Our opposite reciprocal slope is going to be flipping x squared on top of the 3 and putting a negative sign. Now, I'm kind of happy that none of the answer choices reflect that, because that would be bad, right? What you want to do is to pick an answer choice that is going to be a function whose derivative will produce this. Now, by the time that you compete in Meet 2 of the Continental Math League, you guys are going to know how to integrate. And that's going to be pretty much the thing that's going to bring you home free with this particular problem, okay? And I think that that's going to help finally answer this. Now, I do want to spend just a moment, and I might end up giving away the answer if I'm not real careful, but I'm going to go into the TI Inspire just super quickly and kind of adjust my window here just a little bit. I think you guys can see this okay, can't you? Yeah. Try to center this a little bit here on the content that we're trying to provide. So what I've done here is I've gone in and move my camera up here. Hey guys, here I am. So we're going to go ahead and graph the function -3 over x plus k. And notice I'm going to graph it so that k is a slider. And so that will allow me to change the value of k, right? This is a minimized slider. Now, I've also gone ahead into the y equal menu, which I can access by hitting the tab feature. I might want to get off that slider first. And you'll see that I have every one of the answer choices in some random fashion sketched. And it turns out that only one of these will reflect that perpendicularness. Now, maybe it's this one, guys, -1/2 x squared. Let me check that one on and see if that looks like it's perpendicular to the curve at every point x. And who knows, maybe we're perpendicular there. I don't know if we are or not, to be honest, but I don't think we're going to be perpendicular all the time, right? So I don't think that was a good option for us. So I could turn that off by going back into my tab menu and say, no, I don't think I like that pink line that I have in there as F4. And so maybe I'll try another one. I don't know, maybe I'll try this one. I don't even know what choice that is. And I back up and I look at that and I think, oh my goodness, does that look perpendicular to you? I think that might be perpendicular in both places. So anyhow, I hope this helped you. We'll see you next time.